My name is Dr. Philip Webster. I'm a scientific community engagement manager at Belsera, and I'm going to speak to you today about bringing your own data and data management on Biodata Catalyst powered by Seven Bridges. I myself have a long background in genomics and in bioinformatics, so this is something that's proven to be a pretty powerful tool that I've been able to utilize myself and also has helped in helping researchers who have onboarded onto the platform. And so why would you want to bring your data to BioData Catalyst? The first strength of the platform is that there's immediate scaling. You don't need to wait to purchase or install any hardware or have software that needs to be installed on every computer in your lab with you paying for licensing for every computer it's installed on. It really helps to push forward a lot of data analyses. So you can see on the right under the old previous model that generally you'd have a lab that was producing data and they were sending that data out to be computed by a bioinformatician or in their core, and then that was sent back to them, and there was a lot of back and forth. But now with our model at Biodata Catalyst, every researcher is working on the platform. They're hosting their data or linking their data on the platform and doing their analyses and collaborating together. And so this not only lends itself towards the goal of reproducibility, which is the goal of not only researchers, but the NIH. It also leads to leveling the playing field for universities or institutions who may not have high processing clusters, HPCs, or not have the computational resources themselves. And it allows a lot of data analysis and methodology in one place. And so how are the ways that you can bring your data to BioData Catalyst? There's a few ways, and all of them are equally pretty simple. The one that you're seeing that's being illustrated right now is an import of DIRS manifest, which can be generated by any of the external repositories that you may have seen in the previous presentations, such as proteomics, the NIH public proteomics data commons, and you can generate a manifest from there, create a project on BioData Catalyst, and using that manifest to link to the files of interest on that external repository. And then without having to pay to host the files yourself, since they are still being hosted on the original database, you can then work with those files for analysis. If you have another method that you need, such as uploading your own files or a file from another source, maybe it's an AWS or Azure value, you can also connect that to your project. So we just have a myriad of tools from command line interface to direct interaction with different volumes and storage for you to bring your data to the platform. And so what is the typical workflow for a researcher to work on the platform? And as I mentioned briefly, you would first create a project on the platform for your organization. And in the next slide or two, I'll explain more about how you can do that and control who has access and disseminating your data throughout your group or consortia. And then you would then select and access your data. So that would be the DIRS manifest or uploading your own data, connecting a volume, or using the command line interface. And then you're going to select one of our many tools. We have a lot of analytical tools, which I will also cover in the next 2 slides or so, for which you can use to analyze your data either in data studios that host Jupyter notebooks for R or Python, or in one of our already wrapped tools that are ready to go for input and outputs. And then you can create and run your analyses with these tools. And of course, you can share those results with other people in that project, or share them throughout or between projects and owners. And so this is an example of the complete control over the data and permissions that you would have over your project. So if you had somebody who was and I'm just going to change my pointer for a second so to make this more clear. If you have someone who is the admin or the project owner, and they're the ones who create the project, that admin has the power to add collaborators with different levels of permission. So someone who can only read the files, but cannot download them, someone who can, download the files and take a look at them, maybe run some analyses, and then someone who has almost equivalent admin privileges. They can't control everything, but they can add other members and control some of the permissions for some of the other tasks, files, and apps that are generated. And the admin and the user can select the files, apps, and parameters to create tasks for, and really control where that data goes, which users can copy the data, if that data can be downloaded at all, even once copied to another project. So a lot of those protections are maintained. Excuse me. Sorry. Okay. And so what another strength of the platform is that you can also bring your own pipelines and workflows to it. Using this method, the platform uses tools that are wrapped in common workflow language. And so with this method, you would bring your tools in. Someone on our team here at Belcera can help you wrap your tool within common workflow language. If there is a tool that is already available on the platform that you would like to use and maybe do some edits or link it to another tool for a more complex analyses, you can do that via our UI system here within a project on the right, where you can interactively through a Visual Studio create those new workflows and projects for your own use cases. And then you can share those and publish those throughout the community that you are a part of. And we have helped many people bring their custom analyses to the platform and make those public projects that are available for everyone who signs on to use. And so how many workflows and tools are available for you to use? Well, up to date, there are over 800 bioinformatic tools and workflows. We optimize them for speed and cost. So there is a lot of extensive benchmarking that we do with the researchers that create the tools, as well as tools created from our team, to make sure that they are as efficient as possible. The tools are fully parameterized and customizable. So what that means is that if you did want to go in and change a parameter, how files are read in, if files are combined or flattened, how the outputs and the types of outputs that come out from your analyses, you can do that. And they're parameterized in that whoever creates the tools, or if you want to just use the default tool, then you can set default parameters that run without the user having to worry about running them themselves if it's a type of workflow where that is useful. And then you can also access these workflows via not only our user interface, but also through API, through command line interface or API tools. And we also make sure that every tool has sufficient descriptions, what types of inputs it takes, as well as the file types that are required. And with that benchmarking, tools usually have about how long and how much it will cost to run that tool, just for you to get an idea of in general. And this is just another example of how you can search for these tools by category, by name, very easy to find for your needs with your data. And so lastly, before I end, I would like to promote our office hours with Biodata Catalyst. I and my colleagues meet twice a week, Tuesday and Thursday. Tuesdays at 10 a.m. and Thursdays at 2 p.m. for one-on-one coaching, platform support. Like I stated earlier, we've helped people generate their own workflows, get through technical issues, as well as upload and access their own data or data that they are interested in on other repositories. And that is all. Thank you.